Hello Greenfoot coders, it's Michael here. Welcome back to the Joy of Code. In today's episode we will pack a lot of stuff in there and go reasonably quickly over things, so pay close attention, sit back and watch. What I'll do first is I will introduce another food source for our turtle. So at the moment we can run around and eat the lettuce, so I want to have the turtle also eat bugs. So I create a new subclass. We have been through this before. Oops, what's happening here? New subclass, oh there it is. I call it bug and I look for an appropriate image. There's a ladybug image. Let's take that one, so that's my bug. So what I want to do is I want to put a couple of bugs in there as well, so I can really save the world to have my bugs in there. But the difference to the lettuce is that the bugs actually move around, so while the turtle can eat the lettuce quite easily because it doesn't move, I want the bugs to crawl around as well, and the turtle has to chase them to eat them. So first what I will do is I will copy the moving code out of the snake to the bug, because the bug, just as the snake, should just move around randomly. So I go to the snake and I take essentially the whole code inside the body of the class and I copy this. I just did a copy with my keyboard. I go to the bug and I replace this here with the copied code. So here I've got I want to move forward. I've got a rubbish comment in here from my last session. I want a random turn, I want to turn at edge, and I don't want to try to eat a turtle, so my bug doesn't eat turtles. I'll take that out. There's my random turn, there's a turn at edge. Try to eat turtle I don't need. My bug does not eat turtles, it just moves around. Let's look at this. So if we run this now, the bug moves around randomly. Okay, at the moment there I just ran over the bug, nothing happens, so I need to modify my turtle so that it is able to eat bugs. So here, where I said try to eat lettuce, I changed the name to try to eat because I try to eat anything. I need to also change it here, of course, try to eat. Check, and the comment says check whether we can see lettuce or bugs, and then if we can eat it. So if we can see a lettuce, we eat the lettuce. Well, first of all, the game over thing, I take that out. I take that out here and I move it there. Oh, now my indentation is all messed up. You can in edit just go to auto layout, which will just fix up your indentation for the whole class. So here I've got the lettuce eating, and I just duplicate this. And I say if I can see a bug, then I eat the bug. And now lettuce eaten doesn't make so much sense. Here I have counted how much lettuce I have eaten. I don't want to separately count my lettuce and bugs. I want to give myself points for everything. Let's say every lettuce you eat gives you 1 point, and every bug you eat gives you 5 points. Because they're harder to catch, they're running away from you. First of all, the name of my variable, I still use that variable for counting my points, but the name doesn't make much sense anymore because it's not only for letters, it's for points in general. So first of all, I rename my variable. So here I want to rename it everywhere. So what I can do is I just go to where is it? Replace. There's a replace where I say I want to replace lettuce eaten and replace that with points, and I want to replace it everywhere, replace all of them, and that's it. Now everywhere there it says my points is 0, and here points are incremented, and if points is 10. Now if I eat a bug, at the moment I'm just giving myself 1 point when I eat lettuce and 1 point when I eat a bug, because this plus operator increments the variable by 1. For the lettuce, that's fine. I want to increment it by 1. Here, I don't want to increment it by 1. I want to give myself 5 points. The way I do this is I write points is assigned points plus 5. This equal symbol is an assignment operator which assigns whatever is written on the right hand side to the variable on the left hand side. So it evaluates the right hand side and then stores the result on the left hand side. So what happens is here we read out the points variable, then we add 5 to it, and the result gets stored back into the points variable. So the result of this statement is that points gets increased by 5. Now I want to put that up a bit. Let's say we need 15 points to win. Because now that a bug counts 5 points, 10 points is a bit too easy maybe. So you need 15 points. You get 1 point for lattice, 5 points for bug, and with 15 points you win. Let's try that out. Let's see whether I can actually eat my bugs now. Let's try to catch one there. Yep. And let's just investigate. Inspect the turtle. We have 10 points. That looks about right. I've eaten one bug and a few lettuces. Okay, so that's the first thing. Oh. And there I got eaten. Okay, that works as well. So what we've seen here at the moment is what was new is the assignment operator. Here, with the equal sign, which is formally called the assignment operator, I can assign a value to a variable. And in fact, we had seen that assignment operator here. I assigned 0 to this variable initially when I created it. Okay, now more interesting even is the next thing I want to discuss, and that is object interaction. Objects can talk to other objects. That is, one object can invoke a method of another object. And the way I want to make use of that right now is I want new bugs to appear in the world whenever one gets eaten. So when I eat one bug, a new one should just pop up. And I can do that by talking to the world. The world itself, this whole area that we're seeing here, is an object as well. And I can talk to that world object and tell it to put a new bug in when a bug gets eaten. So let's try. First we have to find the place where the bug gets eaten, and that is here. That is where the bug gets eaten. And then I give myself my points, I play the sound, and then I say create new bug. And create new bug doesn't exist as a method, so I make a method here for that. So I'm say public void create new bug. Just as a remark forward, we haven't discussed that yet. This actually should probably be private, and I haven't discussed the difference between making a method private or public yet. I will do that in the next episode, so for now just believe me, and I will discuss the difference shortly. So I'm creating a method called create new bug that gets called here after I eat a bug, a new one gets created. Now I can create a new bug by writing new bug. When I create an object of a class, I can pass, there's a way how I can pass parameters to the object at the time of creation. That has to do with constructors, which we also haven't discussed yet. As long as we don't have any constructors, which we don't, there will be no parameters. So I write an empty parameter list, just like in a method call. So 2 round parentheses means I am passing an empty parameter list. So I'm passing no parameters to this bug when it is created. So this instruction, this is a Java instruction that will create a new bug object. Okay, now we have created a new bug object. We have to do something with this bug. We can't just have it floating in space. I need to do something with it. What I will do is I will store it in a variable. And for that I need a variable that can store a bug. So here I write bug, new bug. This here is a variable declaration. This declares a variable, and I said before a variable declaration has a type and a name. that is the name of my new variable. So I'm creating here a new variable called newBug, and the type is bug. Now there are two new things here compared to the variable we had seen before. The variable we had seen before was up here. That was a field. So there the variable consisted of its name, its type, and the word private in front of it. This here is called a field, or sometimes also called an instance variable. That's a variable that is stored in the object, in the turtle object. If I declare a variable inside a method, which I can do here, it is called a local variable. A local variable is a variable that I only need for a short time. It will only exist as long as this method here executes. And once that method is finished, that variable will be thrown away. So it's a variable for a short purpose that I need temporarily but don't need to keep around for a long time. If I have a local variable, one declared in a method, it does not have the word private in front of it. So it consists only of the type and the name. That's the one thing. So, well, that was two things already. The location of the declaration is different. It is inside a method instead of at the beginning of the class. And the second thing, it has no private in front of it. Now the next new thing here is the type. What I'm seeing here for the first time is that the name of a class, in this case this bug class, can be used as a type for a variable. So we had before seen a variable of type int, and int, remember, was a type to store numbers. We can see that we can also have variables of types of other classes. Then the variable can store objects of that class. So if I declare a variable to be of type bug, it can store objects of type bug. So this declaration here just gives us a variable that can store bugs, but it doesn't actually give us a bug yet. It only gives us a variable that is able to store a bug, but the variable is empty initially. Now here I can write an assignment statement that looks like this. So here I'm creating a new bug object and I store it in my variable. Okay, now I have a new bug, but this bug is not in the world yet, so I am holding the bug in my hand here. In fact, I'm holding it in this variable. And the other thing I need to do is I need to stick it into the world now. So I need to tell the world to add this bug to it. To tell that to the world, I need to first get the world. So I create another variable, which I call is of type world, and I call it world. And I assign the world object, and we can see if we look at the documentation, Greenfoot class documentation, look at the actor class, that the actor class has a method called getWorld that gives me the world object that I am currently in. So if I say getWorld, if I call this method, this will give me the world object. And now I have the world object stored in my world variable. And now I can say world dot, I'm saying to the world, add a new object for me. Let's look at the documentation again. And this time we look at the world class. And we see that the world class has a method here called add object that has three parameters. It has an actor object as the first parameter and an x and a y coordinate as the second and third parameter. So I can say to the world, add object, and then I first have to provide the actor that I want to add. That is my new bug here. So I write new bug, and then I have to provide the x and y coordinates where I want to edit. Let's say we just arbitrarily choose 100, 100 for the first try. So in our world, 0, 0 is top here, so we're going 100 pixels to the right, 100 pixels down. It will edit roughly here. Somewhere there is my 100, 100 point. So that is where my new bug should appear. So what I'm doing here is, let's delete that empty line here. What I'm doing here is I'm getting access to the world object, and here I'm talking to the world object by saying world dot add object. I'm saying to the world object, world, please add this object for me. Or in more technical terms, I'm invoking a method of a different object. I'm invoking the add object method of the world object. This is called dot notation. Dot notation is a Java notation to talk to other objects, where I write the object I want to talk to first, then a dot, and then the method I want to invoke, and then the parameter list for that method. So this method here should create a new bug and add the new bug to the world, and that should happen every time a bug gets eaten. Let's try that out and try to get one of the bugs, and you see as soon as I got it, a new bug appeared at the top left, and there it appeared again. This is already pretty good, but let's just do one more thing. At the moment, the new bugs always appear at the same spot. I want the bugs now to appear randomly anywhere on the screen. So I essentially want to be the coordinates here. I want them to be random. So let's give them variable names. Let's call them x and y. And here I declare int x and int y to be two variables. And now I need to, between declaring the variables and using them here, I need to assign random values to these variables. I can either do that by now writing an assignment x equals something, or in fact I'm also allowed to write the assignment directly in the same line as the variable declaration. So I can write it here. I can in the same line declare the variable and assign a value to it. That is perfectly allowed, and we know already from the random walking of the snake how we get random numbers. We write Greenfoot dot get random number and the limit. And the question is, what is the limit? The x, for the x, the limit should be the width of the world. I can look into the world class, and I can see here that is where the size of the world is defined. It is 600 cells wide, 480 cells high, where every cell is 1 pixel in size. So the width is 600, the height is 480. So I use 600 as a limit for my x, and I use 480 as the limit for my y. So I'm taking a random x, a random y, and use these random values as the coordinate for my new bug. Let's try that out. Now let's try to get one of the bugs, and there one bug appeared at the lower left somewhere. Let's chase that one, and it appeared again at the lower left. So I'm not really sure that that was really random. Let's try that out again. My game finished before I could try that a second time. Okay, yeah, you see now the bug actually appears at a different location every time. That appears to work well. Before we finish, one last improvement, and we will use a variable again. Using 600 and 480 for the size is not the best way to do it. It's not considered terribly good style. It is correct now, because our world, as we have seen, is 600 by 480, but it is a somewhat risky way to write my code, because if I later decide to make my world bigger, I might change the numbers here and then forget to change the numbers there, and then my code is incorrect. If I make the world smaller, this will be outside of the screen, which is not good, or if I make the world bigger, then some areas of the world will never be used. So instead of hard coding the 600 and the 480 there, I can just say here I want to use the whatever the current width of the world is. So I can have here another variable which I called world width, and I have already my world object here. I can get the world width just by asking the world, how wide are you actually? Let's look at the documentation somewhere here. We are in the world class here. It has a getWidth method and a getHeight method. So I can just ask the world, how wide are you actually? So I can say here world.getWidth. And then I'm duplicate this and do the same for the height. I say world height is world get height, and then here I use the world width for the limit for my x, and I use the world height for the limit for my y. And now, whatever the world width and height is, the random number will always be selected out of the correct range, and the bug will be placed anywhere in the world. So take a few minutes after you watch this, maybe watch it the second time, to think about this. This is the most elegant way to do this. I also need to add a comment, of course, to make this create a new bug and insert it at the random location. You should always add comments to your methods. So let's try that out. Now, if I have done this correctly, it should just work again as before. The bug should be there. I've got one added at some random location. Yes, it works. And there we go. Okay, sad trombone, but we are done. In fact, it's not sad at all. This is a good improvement. And now we have seen two very important things here. First, we have seen more uses of variables, variables of class types, another variable of a class type, variables of int types. We have seen local variables, and we have seen object interaction explicitly for the first time, where one object talks to another object. In this case, the turtle object here talks to the world, here and here. We will discuss object interaction much more in many of the coming episodes, because that is one of the most fundamental concepts of object-oriented programming. Just about every program is made to work essentially by objects talking to each other. But this is enough for one day. Think about it, try it out, have fun. Until next time, bye-bye.